Hey folks, Knox with IT Inspired here. Really excited to talk to you about this one today. This is going to be a three-part series guiding you from start to finish on getting started with Docker and Linux. If you are a Windows sysadmin and you have no experience with containers, no experience with Linux, you have no idea what they do or why they matter, what is even going on here, you're in the right place because I'm going to guide you through it. I was in your shoes not too long ago going like, what is going on with Docker and containers? Why does this even matter? And I've got a little bit of experience with it now, and I think it's really interesting, so I wanted to share it with you. Containers have been picking up a lot of momentum in the past couple of years, not too surprisingly coinciding with when Microsoft adopted support for Docker and started pushing it super hard on the 70-740 exam. So if you are looking for any reason to be interested in this, know that it's a focus on the path to the MCSA. This technology is primarily used by developers and DevOps, but there are a couple useful containers that I'm going to show you, the sysadmin. Also keep in mind that this technology does run on your infrastructure, so you should probably know what it is and what it does and how it's impacting your hardware anyways. It's not hard, but there is a decent amount of command line to get through to do this right. So, without further ado, why don't we get going? As you can see, I've got paint up again, so you're going to have to suffer through my drawing, but here it goes. All right, virtualization. Virtualization used to be this all-encompassing term where we know what virtualization is. Well, not anymore. We know what hardware virtualization is. So here we've got our server, and it's running ESXi or Hyper-V, and it's got 24 cores and maybe 128 gigs of RAM. And what we would do is we would take up that hardware and dice it into smaller pieces of hardware. So you get 2 cores and maybe 8 gigs of RAM or something. And this guy would get 12 cores and 24 gigs of RAM. I don't know. And this thing would think it's its own self-contained piece of hardware. That's not the case in Docker anymore. That's not the case with containers. What they do, I'm going to kind of draw it more like rectangles, or like this. A little server on its side. I'm sorry, Mr. Server. What they do is they don't virtualize the hardware, they virtualize the operating system. So when we take this hardware and we install Windows Server 2016 on it, it's got the Server 2016 kernel, and then an operating system environment running on top of that kernel. When we start pulling and downloading Dockers, what they do is they take... Where'd my mouse go? Ooh, sorry. They take... they download an image of the operating system here, and it shares this kernel with the base operating system. So it's virtualizing the OS. Now, this machine, these operating systems, so this guy's got the base machines, it's going to have an IP of 10.10, make something up 50.50 or so, I don't know. What's going to happen here is this OS is going to create its own little operating system environment with its own IP address. The default is to actually do this behind NAT. So this will all be in, all these containers will be probably in the 172.16.0.0/12. So that'd be 16 through 32. And when we go to access these containers, like maybe this container here runs a website. So it's going to be, maybe this will be an IIS container. So it's got this is going to be its own little Windows Server 2016 running IIS on it. We'll just kind of write this IIS right here. What we're going to do as the end user, if we want to go view this website that's running in this isolated container, so it's not impacting our underlying operating system, we would type in the destination address of 10.10.50.50. It would go to this operating system. We would obviously allow that in the firewall. And it would know, based on how we set up the container, to port forward that in to this isolated container. So if something happens to this container right here, if it gets corrupted or something, it gets blown up. It doesn't impact the underlying operating system. It doesn't impact the other containers that are running on it. Like I said, this is just a different way to virtualize your infrastructure, and it's very, very easy. It's 1 or 2 commands, which is why developers love it. The process of building VMs and taking that time to install the operating system and hard carving out that slice of RAM out of your underlying physical hardware is gone, because we can set these limits and everything in the container itself, or we can just let it be dynamic because it's going to be sharing that kernel. Now, Windows Server 2016 does take this a step further. We're sitting here talking about sharing this base kernel. So let's say I'm running Server 2016 version 1607. What if I want to run a nano server container running 1709? Well, I don't know where that came from. Sorry. Let's let's get rid of that and go back to my. Actually, it's a good opportunity to use a square. That'll make this look a little prettier, right? Oh, look how much better that looks. So let's say this is going to be Windows Server version 1607 here, and I spin up a I want to spin up a container that is going to be Hyper-V. It's going to be Nano Server 1709. These are not matching kernels anymore. So what Microsoft did when they partnered with Docker is they enabled Hyper-V isolation, where it no longer shares the base kernel. It runs a tiny kernel within the container itself, so that you can actually run different versions of the operating systems as isolated environments on top of your infrastructure. So, just to show you a little bit more about what's going on with this, I think that's about enough for the whiteboard today. It is a little complicated, but summarizing, it's different from hardware virtualization because we're just going to be sharing the base operating system and kind of dicing up these little OSs into their own little environment. So Microsoft partnered with Docker. Docker was the leader in this. And they definitely have the most stable platform and the biggest repository for getting containers up and running. You can install Docker on Windows 10, and if you choose to do the Edge channel, if you've got Windows 10 Pro, you can actually run Linux Docker containers in your Windows 10 machine. What it will do is it will actually install the Hyper-V role and then create a tiny little Linux VM in Hyper-V and use that to share the kernel for your Docker containers for Linux. It's very cool. I do highly recommend checking it out. Windows Server 1709 claims to support running Linux containers. I have tried at least a dozen times to get it working and can't. What I have found works best, and the method that we are going to go through to get Linux containers working on Windows Server is just to spin up a Hyper-V VM of CentOS version 7. I am going to walk you through creating that VM, installing CentOS. So if you've never touched Linux before, if you have no idea what to do when it comes to installing Linux, that is going to be part 2 of this series. And then we're going to go into Docker on part 3 itself, actually running the commands and getting this thing up and running. Some other things I wanted to show you just to prove to you, you can actually pull as many Windows Server Core or Windows or Nano Server images as you want. The command to download any of these images is docker pull. We're going to go into that a lot more in the third, and then you would want to do Microsoft/Windows Server Core. Now, you can put a colon on the end of this Windows Server Core and specify your versions. If you don't put a colon on the end of it, it's going to default to latest. And that, as you can see, is going to be Server 2016 long-term support. So if you're running Windows Server 2016 version 1607, which is the current long-term support, you can just pull this and run it. You don't have to use the Hyper-V isolation command. However, if you do want to use version 1709, you'd issue this command, :1709, and you would have to probably spin it up on Hyper-V, assuming you're not running version 1709. Now, The repository itself, where all these images live, is called the Docker Hub. I'm going to show you how to work with that from the command line in the third video. It is pretty straightforward. There is seemingly an infinite amount of open source Docker software that you can download. And like I said, you as a sysadmin may not be interested in development tools so much, but there are a couple things out there that I think are great, and you should definitely give them a shot. And we are going to go over that. All right, are we ready to begin? Let's get started with creating a virtual machine that is going to run Linux in our Hyper-V environment. So here's my Hyper-V environment. Hopefully you've seen it by now. We're going to go to New and Virtual Machine. Yeah, we've seen this. In fact, don't show me this again. I know. All right, let's call this Docker. And I'm going to store this on my cluster shared volume. Let's go here, volume 1, that's fine. And we're going to call this Docker. Next. Generation 2. If you can help it, if you're running a newer version of Windows Server that has a newer version of Hyper-V, you want to use Generation 2. It is definitely built for new features, new virtualization features. It is based on the UEFI firmware, 64-bit support for guest operating systems. I mean, the list goes on. We really don't have time to talk about why Generation 2 is so much better, but just trust me, it is. All right, RAM. So, you know, some of these containers are a little hungry for the horsepower. So just to be safe, I am going to give it 8192. And I'm not going to use dynamic RAM. I want to make sure this container host, as they're called, has plenty of horsepower that we can use here. Next, I'm going to connect it to my external data because I want it to have accessibility to my network. All right, let's create a VHD. I'm going to leave this as the default because some of these containers could also take up a lot of size. It is dynamically expanding, so you know what thin provision is by now, hopefully. If you don't know what thin provisioning is, basically it means I'm going to make it a 127 gig hard drive. It's going to show up to the operating system as a 127 gig hard drive, but it's not going to actually eat up 127 gigs. It just takes what it needs and grows as it needs. And let's go ahead and mount the operating system for CentOS right there. Perfect. Great. So that's it. We've got a VM created. I'm going to click Finish. Woohoo! There's Docker. Now, real quick, I am going to give it a little more horsepower. Let's go up to 4 cores. And this is important since we're going to be installing Linux. When you've got Secure Boot enabled, Microsoft Windows is obviously not what we're installing, right? You go to boot it and it's going to throw this error. We need to do the UEFI certificate authority. Okay, super. Now, one more thing. I'm going to do this for good measure, even though it's not entirely necessary. If you are installing Windows and not Linux, you want to enable nested virtualization, meaning that this Docker container is going to be, this is a Docker VM, and it's going to be running virtualization within itself too. Especially if you're running Hyper-V, you can't even install the Hyper-V role on a Windows Server VM unless you do this first. That command is set VM processor, VM name, and I called it Docker, enable virtualization extensions. True. This will allow the processor on this VM to show up as capable of handling virtualization. And then I can spin up Hyper-V VMs. I can spin up, all these containers. Like I said, it's not entirely necessary if they are going to be sharing the exact same kernel. But it's something, you should just get in the habit of doing, especially if you're going to be doing this in Windows Server VMs. And there we go. That easy. Another thing that I am going to do before we get started is go into my network adapter and go to Advanced Features and enable MAC address spoofing. Again, because the default is NAT, this is not going to be a huge deal. But in Windows Server, it has the ability to do what's called transparent networking in Docker, which means the containers are passed through to the physical network just like an external switch. So when you've got this VM, essentially is that container is passing in a frame to this VM, and that VM will then pass the frame into the external switch on my Hyper-V host. It's going to have to spoof the address. Otherwise, it's going to be a security risk, and Hyper-V will reject all of the frames from the container. So you do have to enable MAC address spoofing if you plan on doing transparent networking. So I'm going to do that for good measure too. I thought it was good just to show you. This won't impact anything in our environment here, so I'm just going to hit apply. Okay, that's it. That's all we have to do to get ready to prep our environment for a Linux container host. All right, in the next video, we are going to walk through the steps to install CentOS. It is very easy. It's going to be a short video, and then in the third video, we're going to dive right in to getting Docker up and running with a couple cool containers that you may like. All right, get out there and try it out. We'll see you in the next video.